Hey, it's Rick. Welcome to the channel. I recently got a C02 laser. It's in my standalone unheated garage, and winter is coming. I've got a water chiller to keep the tube from overheating, but I need some way to keep the water from freezing. It's a tricky situation. Some people say it's okay to use something like antifreeze, while some say you should only use distilled water, as anything else will increase the conductivity and reduce the power output. Now, I don't know what the correct answer is, but I've decided to use this aluminum tank. It's an overflow for a vehicle's radiator and this 100-watt programmable aquarium heater. I got both of them on Amazon, and I'll put a link for these in the description. Now, as you can see, the heater doesn't quite fit into the opening. There's a bit of a lip at the bottom of this hole. The outside plastic protector can be removed from the heater, but not all of it, so I think it's best to open up the aluminum a bit. I mounted it on my mill and used the boring head to remove about 1 millimeter of material. I removed the burr that was left with a round file. Honestly, I probably could have done all of this with just the file, only a little had to come off. I drilled the hole in the aluminum lid for the heater cable. I drilled it off center so I've got room for more holes in case I need to add more heaters. Next, I cut the heater cable and stripped all the wires. I feed the cable through the lid. It's a really snug fit. I add heat shrink to the cables before I solder everything back together. When the soldering is done, I use a heat gun to shrink the tubing. Then I shrink the large tubing over the whole thing. And this is how it looks now. The next step is to sort out all the holes on this aluminum tank. They've got this thing on the side. It's supposed to be a sort of a sight glass so you can see how much coolant is in the tank, but I don't want it, so I'm going to remove it. I picked up these brass fittings at the hardware store. They're national pipe thread. They seem a little loose in the holes, like the threads aren't quite a match, but I've coated the threads with Teflon tape to help seal them up. This is the final result, with one connection bottom right and one top left. I went with an aluminum tank over plastic due to the fear of it melting or leaking. The next step is to put the heater in the tank. I've already flushed it out with high-pressure water to get all the aluminum shavings out from the boring and filing process. Now I need to install it. I screwed it to the wall behind my laser and used some silicone tubing to connect it to my existing setup. The water flows from the chiller to the heater, then to the laser and back to the chiller. I filled the whole thing with distilled water to avoid air pockets. When I first fire it up, water leaks out of the top hole where the wire goes in, so I added some silicone to seal that up. Unfortunately, I underestimated the amount of pressure this thing is under, and it still leaks past the silicone, even after having 24 hours to dry. I did some research on the internet and determined I needed one of these. It's a waterproof cable gland. I had to order them off Amazon, link in the description, and it was roughly the same price for a bag as a single. The first thing I need to do is enlarge the hole in the lid to accept the gland. You can see there's not a lot of thread available. The lid is too thick, so I'll need to thin it out with an end mill. I reduced its thickness from about 4 millimeters to about 2 millimeters. And this is what it looks like now. The next step is to go through the whole soldering process again and reattach the wires. This is what the whole thing looks like now. I moved the tank down a lot. I thought it being so much higher than the laser tube and the chiller would make it prone to trapping air bubbles. When I fired this thing up, it was 10 degrees Celsius in the garage. I set it to 17 degrees Celsius, and when I returned to the garage about an hour later, the chiller reads 17 degrees. Obviously, you'll need to set your chiller to a higher temperature than this, so they both don't run at the same time trying to compete with each other. I don't know how well it'll work when it's really cold outside, but I'll come back here and post an update if I have any problems. I'll only need to run it over the coldest months, and then I'll just unplug the heater for the summer and leave everything else attached. Well, that's it for this one. I hope you found this idea useful. Don't forget to hit all the buttons on your way out, and thanks for watching.